Okay, welcome everyone to our interim meeting. So let's get going. Reminder, not well applies here. So if you're not familiar with it, please familiarize yourself with this. So today we will talk about Depop. I just want to remind you that we have one more meeting next week to talk about a new individual draft, the AS issuer identifier in authorization response. So it will be next Monday at the same time here. Today, again, it will focus on Depop, and I think Brian will be taking us through this one. Any questions, comments about our plan? Okay, so Brian, I'll stop sharing and I'll give you a chance to share.
Thank you. Hopefully be able to figure this out.
And before you start, I want to again share that link in the chat here, and people that join, please add your name to the list. Okay, Brian, take it away.
Take it away, everyone. Feels silly even asking, but the slides come up okay? The intro slide, everyone see it?
Yes.
Okay.
Yeah.
So we are not meeting in Bangkok, but I love to keep some photos around and throw them there. So we should have been in Bangkok, but instead we're having this virtual interim meeting, as Rafet already said, to discuss Depop. So with that said, here we go. So real quick, sort of a small group, so I'll try to cruise through the sort of introductory stuff, but I still want to cover this. What is Depop and what isn't it? It's a pragmatic application level sender constraining of access and refresh tokens for OAUTH, and does that by binding a key pair in a trust on first use style that's controlled by the client to tokens. What it's not is it's not an HTTP signature scheme. It's not a new client to authorization server authentication mechanism, and it's certainly not perfect or an infallible solution. It has its warts, but it is useful and pragmatic, though not perfect. Real quick overview of what it is. Basically, this thing called a Depop proof JOT is sent as an HTTP header of each HTTP request, and this demonstrates a reasonable level of proof of possession of a key in the context of that particular request. These proofs are sent the same way with the same syntax and semantics for both kinds of requests: to the token request for new tokens, to the AS grant type requests, token endpoint requests, as well as to protected resources. The AS uses this proof to bind the tokens that it issues to the key pair that the client has, and the RS uses the proof to verify the bound tokens and make sure that the client presents a proof for a key to which the token it receives was actually bound. The Depop proof JOT is sent in a header named Depop, surprisingly, and it looks kind of like this: Depop and then the JOT. The actual anatomy, the inside bits and pieces of a Depop proof are a JOT that hopefully many are familiar with. It's explicitly typed because that's what we do now. We only support asymmetric signatures because it's a asymmetric sort of protocol flow overall. The key for which the proof of possession is being demonstrated is sent as the JWK header in the JWT. So basically, this JOT is saying you can verify the signature with this public key, and in doing so, you get some proof that the presenter holds the private key associated with this public key. That's all in the header. Then in the claims itself, we have some pretty minimal information about the HTTP request. The idea here is just enough information to sort of bind this proof to this particular request, and that's the method and the URI. We have a unique identifier, the JTI, that can be used for some level of replay checking. And we have the issue.time, which we in the document specifies that this proof is only acceptable for a limited window of time relative to the creation time of the proof itself. And being JOT, we don't specify anything else here, but certainly other claims could be included here at, the needs of specific implementations or sort of derivative profiles of this particular document. And there's actually some consideration and thinking of work being done in that area by a couple of different groups and people. So I think it's worthwhile to not have anything more here, but allow for it such that extensions can make use of it. When you make an access token request, this should all be familiar. It's an authorization code request, exchanging that code for tokens. And the only difference with Depop is that Depop header is included here. And this is the Depop proof specific to this particular request. So it'll have post in it and the URI for the AS with the token endpoint. Assuming that all validates, an access token is returned. The only difference here is the token type indicates that this is in fact a Depop bound access token. So the client knows that that is the case. This particular one happens to return a refresh token as well. That refresh token then could be used in a later access token request, and the same things apply. The Depop proof is sent as a header. And in the case that this is a public client, and in this case it is, that refresh token had previously been bound to the same key. So this is a way of binding refresh tokens as well for public clients, which is something that we don't have via other mechanisms other than MTLS, but that has its own difficulty in deployment and maintenance. So this gives an application level way to bind refresh tokens to client instances. And the presentation of it is the same, just the same you would make any other access token request. Quick note that we have some new authorization server metadata. So it's just an array of JWS algorithms supported for Depop proof JWTs. And by inference, just the existence of this indicates general AS support for the Depop protocol. I'm not sure that's the right word. Profile, we need a better word. And then the actual access tokens themselves for JOT-based access tokens and introspection responses, we specify the way in which the confirmation claim is used to bind the issued access token to the public key from the Depop proof. And that's via the CNF claim, the confirmation claim. And then that contains a member that is the SHA-256 hash of the JWK thumbprint of the Depop public key. And this is what binds the access tokens to the client's public key for Depop. And this isn't the only way to do it. Of course, as is always true with OAuth, if you have a specific agreement between AS and RS, you can do this however you want. But the intent here is to standardize the way that this information is carried for JOT and for introspection, because those are some very commonly used ways of doing access tokens and allow for sort of independent interoperable functionality between AS and RS implementations that are not necessarily owned or developed by the same group or same provider or whatever. It gives some interoperability at this level. And then protected resource requests are, as you might imagine, sort of similar. You just make your HTTP request to the protected resource. The authorization header uses this Depop scheme and includes the access token. That access token is bound to the key in the Depop proof, and the Depop proof itself is sent in the same way using the Depop header. There is a 401 authenticate challenge. So if you request a protected resource without a token or without any sort of authentication appropriate, you'll get something like 401 with www authenticate, Depop as the scheme, and Realm here, which is in all these challenges, as well as a way to indicate the algorithms that this protected resource or resource server supports for accepting Depop proofs. And then if similar challenge or similar but somewhat different challenge to a resource request with an invalid token, and that would, it's the same Depop www authenticate challenge with a 401, but there's also the error description, and it can also indicate the outage. In this case, though it's likely not necessary at this point, it's possible. These are very similar to the bearer challenges, but with the addition of the ALEX parameter to allow for somewhat more dynamic exchange of the supported algorithms for DPOP. And then get into a little bit of history, status updates, all those sorts of things. Nice transition slide here from Frankfurt. So put together a little bit of history of all the DPOP. I won't go through all this here, but basically the last item is, our last couple items, we're in an interim earlier this year, a bunch of other discussions, and just recently on November 18th, published an O2 revision of this draft, hopefully enough time for people to take a look at it before this post-virtual 109 interim. So we didn't actually have any meetings at IETF 109, but this interim follows closely on the heels of it. And yeah, that's where we're at right now on November 30th. So what's new in the latest draft? And so there's a lot of updates here, but some of the main ones I wanted to touch on and just mention are a pretty broad expanding of the objectives in the draft, trying to better lay out sort of what DPOP does, what it doesn't do, and what it's meant to do in terms of protections. Better describing what it would look like to support mixed or transitional type deployments where you have both bearer and DPOP token types in the same deployment, and more clearly allow for a bound refresh token, but issued in conjunction with a bearer access token. That's somewhat related to transitional type deployments, but also potentially a worthwhile use case sort of indefinitely. So there was some wording that was backed off a little bit, and additional text clarifying that this is in fact possible and legal. Did add and require that a protected resource that is simultaneously supporting both the bearer and DPOP schemes must reject an access token received as a bearer if in fact that token is DPOP bound. And so for a resource that's supporting both at the same time, this is a check that prevents against sort of downgrade type usage. Pulled out, removed the case insensitive qualification on the HTML claim check. That's the HTTP method. It was noted that we had a case insensitiveness there, but those are in fact case sensitive, so it makes sense to keep the claims in line with that. And relaxed a little bit the wording and the requirements around tracking JTI for replay, and also qualified the scope in which it has to be tracked by the URI of the request. So a couple points of discussion that have come up on the lists in various places that were not yet addressed in the draft that I would raise here and talk about and see if we can get some idea of consensus to move forward. Here we've got a picture of Prague, which has already been canceled, but another opportunity to overshare photos here. Too bad we're not going to Prague. I love it there, but not happening. Anyway, so those issues, here we go. There's a few of them. One of the biggest ones that's come up a few times is this issue of sort of freshness of the proof and sort of what the signature itself actually covers on the proof, not the token or anything else, but what the signature of the proof covers. And the big issue is basically that malicious code, cross-site scripting type code executed in the context of a browser-based client potentially create DPOP proofs that are valid in the future and exfiltrate or steal those along with tokens. And together, those stolen proofs and tokens can be used to access protected resources or potentially acquire new access tokens completely independent of the client application. And future DPOP proofs could be created even for tokens that have not yet been issued. And sort of in conjunction with this, also, there's no sort of binding between the binding is from the token to the key. There's no binding from the proof to the token itself, which is what allows for these proofs to be created that could potentially be used for tokens not even issued yet, and potentially allow for some swapping of tokens if a lot of other sort of, I guess I would say, unlikely events came to be, but trying to give a nod to the potential issue that Justin raised previously. There's at least the technical possibility that a proof could be used with a different token because there's nothing binding the proof to the token. It goes the other way around. So kind of the current situation around that is that we have some level of sort of freshness of the proof in the issued claim. But this doesn't prevent some sort of pre-computation by an adversary who can use the private key but not actually steal the private key. So via cross-site scripting or something, that's actually the only vector I can think of, an adversary could create these proofs and future date them so they would be valid for resources at some point in the future. This is largely because there's no server contribution to the content of the proof, and at least in part because the token itself is not covered by the proof or the signature of the proof. I will say that not having like an ongoing or extensive challenge response piece for the proof itself was a fairly intentional design choice, and it was aimed at simplicity and having less overhead in the deployments. But it does sort of allow for this. So some potential options around here. One, quite frankly, is that it's maybe sufficiently okay as it is. This is discussed in the new objectives section of the draft, and key rotation is recommended as a means to reduce the impact of this. And another issue that I don't know how quite to say this, but the attack vector that allows for future dating and exfiltrating depop proofs also allows for direct use. So by sort of trying to mitigate this future generated exfiltrating, we may potentially add a lot of complexity into the protocol and the implementations themselves, while only closing off one variation of an attack that could be used anyway, despite those efforts. It kind of gets into like this nihilism around cross-site scripting, but pretty much if your application has cross-site scripting vulnerabilities, there's not much that can be done practically to prevent attacks through that vector. So just preventing a subclass of those attacks, the exfiltration and usage, I don't know how valuable that really is, or if it's worth the added overhead into the protocol itself. That said, some other options is we could incorporate a hash of the access token, or the access token itself, but probably a hash just for reasonable size considerations, into the depop proof. That would limit at least the scope of what could be done from those exfiltrated things to only using tokens currently issued. This has the same rough mitigation value as having the client rotate keys, but does in the hands of the protocol and not require the client to take some action. Although I start to wonder whether it's, there's a trade-off of the protocol itself enforcing something at the cost of complexity for everyone versus the individual implementations of clients making some action to mitigate something at the cost of just a little bit of extra complexity for them. It also sort of, at least to me, raises the question of whether we should be including other types of artifacts into the proof if we were to do this. Like, is there value in having some kind of coverage of the authorization code refresh token and maybe other grants? I'm not sure, but it sort of begs the question if we were to do it in one place and not the other. But that's one potential option to work with here. Another option, not necessarily exclusive to that, but would be to allow the server to provide, likely via some kind of challenge, some contribution to the proof. In the context of the current design, at least when I think about it, this feels a little bit awkward to work into it in a nice way. Maybe I'm just not seeing it, but I struggle to see how it can kind of fit in cleanly or elegantly. I hate to use that word, but hopefully that makes sense. Like it just sort of doesn't quite fit right, particularly for interactions with the AS. And certainly a challenge per resource invocation of all seems completely untenable. It's already a pretty expensive protocol, and if we were to have a challenge response re-request on every single call, I just think that's too much overhead. So we need to consider some way to amortize the cost of the challenge over many subsequent requests, which is likely possible, but certainly needs to be figured out and considered, and likely has its own complications of some kind of state maintenance and so forth. And of course, the other bullet here is other, because there's probably other ways to consider here, but I don't know what they are, and I think that some combination of one or the other two of these is probably the most likely path forward. So that is the sort of the first of, I think I have three largely open issues. I don't, thinking of the chairs, should I just go through all of them and then come back to discussion on potentially each of these items, or do you want to try to hit that now, or maybe there is no discussion?
I think it would be probably better to do a discussion right now, because if you cover three and then people start, like you have to again for what they should just to start that discussion right now. So, and I see Dick in the line here, but before I let Dick chime in here, I will post the link here, and if you haven't added your name, please go add your name to the list. Go ahead, Dick.
Brian, did you have a chance to look over the binding JWT that I posted to the list?
Yeah, it's not, I mean, I don't quite understand the motivations and rationale, and it's not really something that, I don't know how to say this, it's of interest or need to me, so that's why I have not responded.
Okay, well, because that would also solve this problem, I think.
Maybe so, yes. I guess you could include it in other, via virtue of introducing a whole third artifact.
So, Dick, do you want to describe for people that did not read that? Do you want to kind of briefly talk about that? Or?
Sure. The idea is that you have, as opposed to putting the hash of the key or the fingerprint of the key into the access token or refresh token, that you can use your existing access token and refresh tokens, and you put a hash of the token and a hash of the client's key into a separate token, and then that's a binding token. And so then the resource server verifies that binding token with some key that it has from the access server, which could be the same key that signed a JWT access token, but enables you to use any existing access token and refresh token. And that binding then binds the access token to the key separately in both directions. So it solves this problem. It also makes it easier for people to deploy without having to change their code for access tokens or refresh tokens. So I can imagine, there's lots of people that have deployments out there that are working. Something like this would be able to be deployed as a separate middleware layer for doing Depop without impacting existing running code. It's looking at the access token for authorization.
Okay, thanks. Anybody else has any comments, questions? Any thoughts about what Brian just described here? Or Dick's idea? Okay.
Torsten speaking. Just one question to Dick. I don't understand how the binding between the access token and the key material is being established, because in Depop it's the AS that in the end attests. I have seen that a proof of private key. So I herewith attest that whoever is in possession of a private key corresponding to a certain public key was issued that access token, and I don't see how that this binding is established with your proposal.
I may be wrong, but I believe it's because there's a third artifact introduced that's returned by the authorization server that basically ties the key to the access token, and then the client has to present the access token and that binding thing as well as the proof.
Okay, which means the authorization server needs to be extended to support that feature as well. And
yes.
I don't see how this is even how this is easier than just extending the access token and do it in an opaque way.
I agree with you. I argue that it's changing different sort of bits and pieces of the protocol, and depending on how maybe things have been implemented, it might be easier based on the layering. But all the implementations that I know, mucking with the contents of the access token itself is relatively straightforward and simple versus, or at least manageable, versus trying to issue additional artifacts is less so. So I agree with you, but trying to, I don't know what the word is. Speak on behalf of what Dick was trying to do.
Yep, that was an accurate characterization. It's a separate artifact that enables you to use whatever you have.
Okay. Any other comments, questions? People?
Yes, Philip Skokan here, I'm Zero.
Yep.
So what I don't get is how the resource server would be able to figure out that this is a bound token if the client simply omits sending the proper token type in the header, in the authorization header, in the proper scheme, and also the binding the second header with the binding artifact. Because what we have now is that the resource server can do introspection for both JWT tokens by looking into the claims, as well as talking to the introspection endpoint when they are opaque tokens, and it is able to figure out that this is actually a bound token that it should process the binding check for.
I don't believe that's possible there. So either you can't have an RS that supports both at the same time, or you just are subject to the possibility of a downgrade with that style. That is definitely a negative of the approach.
Agreed.
Okay. Thanks, Philip. There are lots of noise in the background, so if you're not speaking, please go on mute. Mike, can you hear us? Mike Jones, can you hear us?
Hi, Mike Jones from Microsoft. I know that a long time ago when we were meeting in person, Amazon and I think had expressed interest in being able to use symmetric key cryptography efficiencies. I know that, Brian, you and I think Bradley whiteboarded out again when we could stand in front of whiteboards how to do that. Writing that up and describing what would happen to the protocol to use symmetric keys.
Yes, I have thought about it quite a bit. Basically, it would detail out a derivation anyway on the idea that Neil presented around the same time. it's my assertion that it's a completely different protocol. At that point, it's different enough that it would be something different, thereby being different. Can I say different a few more times? But it's really completely distinct in the way that the flow works. And when we were first, early this year, we had an interim on POP in general. And more or less at that point, I put forward sort of DPOP as a working item, or attempting to codify, write up, and actually specify Neil's idea in more depth and so forth. And the working group at that point indicated a strong interest in pursuing DPOP. So I've tabled that other work. Doesn't mean it couldn't come back, but it's not, I consider it sort of closed for this particular document, and would need to be, I think, its own thing and considered distinctly. And it's not something that we can keep sort of considering reintroducing into this document. It's different enough that it just doesn't work. And so it's, I don't know how to say it, it's sort of closed with respect to DPOP. DPOP is a asymmetric scheme, and that's just what it is.
Okay, thank you.
Thanks, Mike. Dave?
Yeah, hi. I suppose, yeah, Brian, including a hash of the access token and other ones, like is it mainly just a size consideration? Why we want to maybe not do that? It just, I suppose, if this was on some sort of backend protocol, I'd have said, yeah, we should 100% do that. I can't see, apart from like the size, I can't see many negatives to including those.
So the hash, the size, the hash, I don't think is a major concern. I think a hash could be added without materially impacting anything. It does bring the downside of having to specify a hash algorithm and either ingrain it or build some sort of hash agility, which has many of its own problems. So there's some consideration there, but they can be dealt with, as you know. There is, to be honest, there's some resistance on my side, basically just because of my attachment to the simplicity of the model and the symmetry between the two types of proof, that the client always sends this proof in the same way, regardless of how it's accessing things. So that it doesn't need to make decisions about what to put in there and what to hash in the context of what request. It just sends a proof, it's related to the request, and sends it off. But I do think, that said, there's probably worthwhile breaking that little idea in order to do something with the access token, and that can be done relatively simply. In my own head, thinking about, well, if we're going to do that for access tokens, then maybe it's worthwhile for these other artifacts, and cleanly specifying sort of how and what artifact you put in there and hash based on the different grant types and requests, which are themselves an extensible mechanism, starts to get a little confusing and potentially sort of ugly. Like, do we say, okay, it's the authorization code for code refresh token for refresh, and then nothing for other grants, or those grants have to specify it, and those grants may have already been written, so what do we do? And it starts to get a little ugly from layering and specification perspective, which sort of helped me to push back on it a little bit. But as I think about it and even talk about it here, I'm wondering if maybe not doing anything for the grant types, doing the hash of the access token for resource access might be a good, worthwhile middle ground kind of thing, largely because of the complexity. And also, I'm not seeing really where you get the value in hashing on the other artifacts. I don't see what that would prevent or protect against, whereas there is value in doing the access token. So I've talked in a lot of circles there, but maybe that explains a little bit of my thinking around it and some of my hesitation to do anything with it. But I'm thinking more that doing the access token and only the access token might be a good sort of compromise.
Yeah, I mean, I do think, yeah, you make some very valid points there, and I think your point about like the type of attack vectors that make those attacks, viable. Like will this really in reality protect? If there's been that level of vector exposed anyway. So yeah, I'm not sure, but yeah, that definitely does sound. I suppose it's just if there is the ability to think of the kind of MTLS, I know it's on a different one, just because it's on that transport layer, it can't be replayed in the same way. So if it was possible, to bind it to the access token itself, that it does seem like it would be sensible. But I suppose if we can't if we can't say that there are definite attack vectors that closes down, then it's not.
I mean, for the access token, I think there are some, at least, that it does close down. Maybe that can be achieved in other ways, but there are some known ones, whereas the other ones I'm less sure about. And that just sort of happily coincides with the other ones being harder to specify too. So I guess that's sort of where I'd lean right now. I know we can't make decisions on the call, but that's, yeah.
Yeah, so maybe we can continue that discussion on the list, Brian, just to kind of hopefully find a resolution to this. Thanks, Dave. Dennis.
Yes, thank you. Well, I just sent a message recently on the list about tonight, well, a few minutes before the meeting, and I got a response from Brian. I believe that we don't speak from the same thing. I'm not speaking in my email about the depot proof token sent by the client, but of the token generated by the AS. And section 8.1, which is part of the security consideration section, is not the right place to state what kind of processing should be done by the ARS when receiving both an access token and a depot proof token. The text says, so basically the text or what should be the core of the document. It doesn't prevent to explain better the ID in section 8.1, that it should not be only in section 8.1. But in section 8.1, there is something important that is written. First, there is a must, and I don't believe that must should be in security consideration section, that should be in the core of the document. The sentence is the following: servers must only accept depot proof for a limited time window after the IETF time, preferably only for a relatively brief period. Well, I believe that this is not the right way to handle that. Some client may wish to be able to reuse honestly the same proof and the same token more than once a day, because they will do different connection to the same RS in the same day. So currently the draft is thinking that there should be only a brief period, and the discussion about the number 32 and 38 are 50 seconds. I believe that when you issue a token, it can be valid for a full day because your attributes are not going to change in a few seconds. Well, if AS believes that the token shall be only valid during a few minutes or seconds, then it uses the expiration date in the token. So I was speaking of the expiration date in the token, not the expiration date.
Okay, but you made the comment about the proof, and this draft is about the proof. So I don't know where you want to expirations in the token themselves. It's an orthogonal issue. It's something completely different. So it's not relevant to this. And I don't even know how to respond to that, because you're talking about things that aren't even part of the draft. Well, I do have some other issues that I'd like to discuss to actually move forward with this. So can we move on?
The discussion was about the time window, and the discussion is not finished about the time window. But at the
The
RS
discussion
side,
was about a point on the document that was the time window for the acceptability of the Depop proof. And then you said something, I guess, about the access token having an expiration claim, although you didn't clarify that, which doesn't make any sense. It's not about this document.
well, reread my email and you will discover what is wrong in your opinion.
Okay, so
Reread it.
let's stop here, guys. So I'm assuming that there is some misunderstanding there. So can we continue that on that mailing list just to make sure you guys are talking about the same thing? We're not going to be able to resolve it here.
That's fair, but I don't have time or energy to address things that don't make sense or that aren't relevant. So I'm not going to expend any more energy on it.
Okay, so.
Well, I mean, it's difficult to achieve consensus and write these documents, even when we're all talking about the same thing. There are limited resources and time and energy. That's just the reality of it.
Yeah, I know. So let's maybe Dennis send an email again and see if he can clarify what are you talking about there, and we'll take it from there, right? If it's out scope, it's out scope. What can you do, right? Okay, let's keep going now. Like on this one, I guess we still want to continue this discussion on the mailing list, Brian. But I didn't see any kind of conclusion here. There is lots of noise in the background. If you're not speaking, please go on mute.
That might be me. I apologize.
Okay, no worries. Okay, so
I don't get a strong sense of consensus around this. I am personally somewhat conflicted, so I'm happy to take it back to the list. But if there's other strong opinions or thoughts here that could drive to a resolution, I would very much like to hear them. Okay.
So let's then maybe take that to the mailing list and continue the discussion.
Fair enough.
So okay, I think Justin is in the queue. Justin, do you want to say something related to this slide?
Yes, just very quick. I just want to point out that for a lot of these, it's important that we keep in mind the first bullet on the right-hand side there, in that sometimes we make the choice to say, yeah, this is a known hole. Here's how you might avoid it, but this protocol is not going to be where it is specifically addressed. And I think that just because there is a shortcoming in a system doesn't necessarily mean that we have to address it in a particular way here, because I was the one that brought up the token coverage question. I wanted to be clear that in my view, we could address that either by adding an access token hash, which personally I'm in favor of, but we could also address it by saying, hi, this signature doesn't cover the access token, so watch out for this.
Okay.
Totally agreed, and not specific to the issue you brought up. That's sort of my point in the first bullet under the ideas is, yeah, it's okay, and we discuss it and try to warn against it, but at the same time, the cost value of adding something, that being access token hash, is maybe worthwhile enough to do it, and so I'm maybe sort of leaning in that direction now.
So do people here, is anybody here, would anybody here object to this kind of direction?
You mean including the access token in the signature calculation, or the?
No, not doing anything about this, right? The first bullet at the right, like the first sub bullet at the right side of the slide, right? So it's
Which
like
I was sort of advocating for, but then also hedging and saying, well, maybe it'd be better to just throw hash of the access token in the proof. So
yeah.
it comes down to those two, and I can try to summarize
Yeah.
those and get that to the list.
Yeah, let's do that, Brian. That's better, just to make sure everyone is clear about the options that we're talking about here. Right?
Okay.
Okay. Thanks, Brian. Yeah, let's go to the next one. Yeah.
Alrighty. Maybe I can figure out how to use my machine. Okay, another issue that's come up now twice anyway is it's been suggested that for resource access, having the JBK in the proof makes it really easy to just use that key to validate the signature on the proof and call it good, thereby missing the checking of the binding to the AT itself in the confirmation claim. Because it's sort of a two-step process. You have to validate the proof and then check that the access token binding is in fact to that proof. And the statement was that that latter check is potentially something that will be missed enough that it's worth considering. That possibility was compared to the none, which I thought was a bit much, but it's sort of the same kinds of things in terms of, is the protocol as it's currently designed making it easy enough or too easy to make a mistake that is believed to be, common or likely enough that it should be changed to avoid the potential for that mistake. And so the current situation is we send the full JVK in the proof, and there's a hash of the JWK in the access tokens confirmation claim. And it's been suggested that missing that check is potentially a foot gun here, something that we could avoid with a different protocol design. That said, there's been only one person sort of advocating this position. I've responded to it and sort of come around to the idea somewhat. It is maybe, from a consensus point of view, it's one person's opinion at this point. But I wanted to raise it here. And really, as I see it, we have two options. One is, again, it's fine the way it is. Just leave it. It's nice to have this symmetry between the AS and the RS access with the proof. It's very, very similar to the way that MTLS, and it's defunct now, but the way that token binding worked, in that the key proof happened sort of elsewhere and the access token was bound to the key. And the idea of checking the binding in a protocol that's about binding access tokens feels kind of fundamental. And although it's possible to be omitted, that feels like something that if you're going to go to the trouble of implementing a binding protocol, you should go ahead and check the binding. But another option would be to change things around a little bit. And rather than a hash of the key, include the full JWK in the access tokens confirmation claim and emit the key entirely from the DPOP proof on resource access. And the argument behind this, again, is that it's much less error prone because you can't just grab the key from the proof and verify it. You have to pull the actual key from the confirmation, thereby sort of implicitly checking the binding just by virtue of pulling the key. So it would be really moving, just that, putting the full JWK into the access tokens confirmation claim and then having it not included in the proof itself. On resource access only, you still need it for authorization server access because that's where it finds out the key. This would potentially be less error prone in implementations. It is somewhat smaller in terms of the total amount of data conveyed between the two artifacts. There's always trade-offs with who's caching what and whether it's a token that's requiring introspection or self-contained or whatever, but just in general, it would be a key rather than a key and a hash traveling between the two artifacts. And it has a nice benefit of not requiring us to define a hash function, which yeah, it's a somewhat side benefit, although it sounds like we might consider adding a hash function somewhere else, so it's not like it gets rid of it entirely. Yeah, so those are really the two options. I see bad in both, and I guess the only other consideration is, even though we're in draft here, we would be looking at what's effectively a breaking change, if in the second bullet, which is always okay in draft stage, but maybe something to think about if we went in that direction as well. So that said, I'm certainly interested in getting to consensus between one of these two options and more or less, picking one and moving forward and putting it behind us.
Okay. Anybody has any thought? Justin.
Yeah, so I definitely get both thrusts of the argument here that, or arguments here that Brian's presented. I think you've done a good job capturing that. And I just want to add that there's a lot of other things, other really bad things that can go wrong if the RS isn't checking the aspects of the access token beyond just its immediate presentation validity. It is aligned with Algnon in that it makes it easy to put a premature finish line in your code and not do any checking past that. But there's a lot of other bad stuff that can happen if, say, the token doesn't have the right scopes, or was issued to a different client, or was issued to the wrong user, or any number of other artifacts dealing with that token beyond just that it was presented with a signature with the key that it was presented with.
Okay, thanks, Justin. Anybody else has any comments? Daniel. Daniel? Daniel, can you hear us?
Now?
No, yeah.
Excellent. Okay. Yeah, I just like to add. So I think this is a very valid point, and we've seen in the past how people implement such things wrongly. But I think there's also a lot of value already when we have a good description on an algorithm how to check these things. So when we make the spec very explicit on what to check and in which order, I think this can already be a good step to avoiding these kind of issues.
Yeah, I agree, but not sure where that leaves us. Whether it's enough or yeah.
Okay. Anybody else has any comments, any questions? We have 3 minutes here, guys, so we're not going to be able to finish the last open issue, Brian. So, and I see that you have really two important open issues here. So I'm thinking that we might need a follow-up meeting to continue this. Is that? Go ahead.
Well, let me take this one on the list too, and at least see if we can gather some feedback to try to get to consensus. It should be easy to summarize because it's A or B. Please pick one, and we'll move forward. And
Okay.
the last issue is hopefully really short, so if you don't mind, I'm just going to pound through it on the slide.
Yeah, go ahead.
If I can figure out how to advance the slide. Oh my god, this is embarrassing. Seems to have. Oh my goodness. I apologize. right, I'll just summarize. It was the fact that Depop is not a client authentication method, and we go out sort of out of our way to say that, but we're seeing situations where asymmetric stuff going, asymmetric client auth and asymmetric binding. You get the combination of Depop and private key JOT for client authentication, which is a little bit weird to have both of those artifacts on the requests that are doing, in some ways, very, very similar things. And by doing some pre-registration or pre-configuration of keys, Depop could be turned into an OAuth client authentication to the AS method pretty easily. Basically pre-registration in some way to carry the client identifier, and I think then it's done. And it simplifies at least the that's where you would otherwise have private key JOT in there. And so it seems like an easy win. I was wondering if people are interested in having that specified somewhere, either in this document, which I actually am not a big fan of because I think maybe it confuses and complicates things. Doing a new document would be relatively short and simple, but specify it there, or just forget it and pretend we never had this discussion.
Okay, I'm not gonna have the we're out of time here, so I wanna ask if they haven't added their name to the list, please do that. Brian, let's start with open, sending those open issues to the list, and if you can close them, that's great. Otherwise, we could consider a meeting to just complete this.
Sure. Let's start with the list and we'll go from there. Thanks.
Perfect. Okay. Thank you, Brian, and thank you all for joining. Appreciate it.
Thank you, Brian. Ciao.
Thank you, guys.
Bye.
Thanks, folks.